Human perception operates on a scale of decades. Because of this, mountain ranges and deep valleys appear to be permanent fixtures of reality. Accelerating time to observe the Earth over millions of years reveals a planetary machine in a constant state of rearrangement. This state of geological equilibrium is a precarious balance maintained by the interaction of two opposing mechanical engines. The first engine is driven by intense internal heat. These endogenic forces act as builders, operating beneath the crust to push mass upward against the pull of gravity. The second engine operates at the surface, powered by the atmosphere and hydrosphere. These exogenic forces act as sculptors, using water, wind, and ice to move that elevated mass back downward. Physical features, from jagged peaks to coastal plains, are defined by the specific way these two engines interact at any given location. To understand geomorphology, we have to look past the surface appearance of a landscape and identify the ongoing mechanical work that formed it. The process begins at the absolute center. The Earth's core operates under extreme parameters, a solid inner core surrounded by a liquid outer layer exceeding 5,000 degrees. This thermal energy radiates into the mantle, a thick layer of magma in slow, constant motion. As magma near the core heats up, its density drops, forcing the material upward to initiate a massive convection current. Reaching the crust, it loses heat, becomes denser, and sinks back toward the core, creating a continuous loop of flowing rock. The Earth's crust sits on top of this moving system. Rather than a single continuous shell, the crust is a fractured surface. Because the crust rests on the moving mantle, these convection currents generate immense lateral friction against the underside of the rock, dragging the continents along. The heat of the core provides the raw kinetic energy required to move entire tectonic plates across the surface of the planet. Tectonic plates are massive rigid slabs floating on the mantle. They drift a few centimeters per year, driven by the mechanical force of the convection below. When driven directly into one another, they form convergent boundaries. The force of two continents colliding is absorbed through deformation. Rock layers are compressed, folded, and thrust skyward, creating mountain ranges like the Himalayas. In areas where mantle currents pull plates apart, they create divergent boundaries. As the crust thins and fractures, it creates a rift valley where magma rises to fill the gap. This magma escapes as lava, cooling and solidifying to build volcanic mountains and expansive plateaus. At transform boundaries, plates attempt to grind laterally past one another in opposite directions. Because the edges are jagged, they lock together until mantle pressure causes the rock to snap, releasing centuries of stored tension as an earthquake. Through folding and volcanic activity, plate tectonics acts as the Earth's builder, pushing mass upward against the force of gravity. The moment internal forces push rock upward, atmospheric forces begin the process of moving that mass back down to sea level. This leveling process is gradation, the mechanical transfer of mass from high elevation to low elevation. Gradation begins with weathering, the breaking down of rocks in their original place. The rock is compromised, but it has not yet moved. Physical weathering occurs when temperature shifts or freezing water crack the stone. Chemical weathering changes the rock's composition through reactions with water or acid, while biological weathering occurs as tree roots exert mechanical pressure to shatter it. Erosion follows weathering. This is the physical transportation of those fragments, carrying debris away. When the eroding agent loses kinetic energy, it drops the material. This is deposition, where sediment accumulates to build new landforms. Weathering provides the raw material, but erosion is the mechanism that reshapes the planet's topography. Rivers, wind, glaciers, waves, and underground water are the primary agents of gradation. Each applies force that leaves a predictable signature in the terrain. Fast-moving rivers in mountainous areas erode the bedrock downward, creating narrow V-shaped valleys. As rivers reach flat terrain, they slow down and deposit their sediment, building floodplains and deltas. Glaciers act as frozen rivers. Their immense weight allows them to pull rocks from the ground through plucking, grinding the bedrock below through abrasion. This grinding process carves wide, smooth, U-shaped valleys, a distinct visual contrast to the sharp cuts made by rivers. In arid regions where plant roots are scarce, Wind becomes the dominant force, moving loose soil that is entirely exposed to the atmosphere. The wind acts as a sandblaster, eroding rock bases into mushroom shapes and transporting particles to build expansive sand dunes. Underground water acts as a chemical solvent. Rainwater seeps into the crust, becoming slightly acidic and dissolving rocks like limestone from the inside out. This creates subterranean landforms, hollow caves, sinkholes, and mineral deposits like stalactites that grow as water drips from the ceiling. Analyzing the shape of a valley or the specific curve of a rock allows us to identify the exact force of nature that carved it. Every landscape is a balance of power and an active physical battle between internal and external forces. We see this interaction across the Indian subcontinent. Along the northern border, the Indian plate collides with the Eurasian plate, forcing the Himalayas higher. Simultaneously, glaciers and the Ganga-Brahmaputra rivers cut into that rock, eroding mass and transporting it southward. As the rivers slow at the base of the mountains, they deposit that material, creating the fertile northern plains. The material removed from the peaks provides the foundation for the land below. On a planetary scale, surface mass is never lost. It is relocated through a continuous cycle of tectonic uplift and atmospheric gradation. The ground beneath our feet is a temporary arrangement. Over millions of years, the Earth is entirely fluid in slow motion.